my wonderful SM1 students. We are going to finish up chapter 12 today, or what it is that we're going to do with chapter 12. This was a very, very, very short unit. We're cramming 12.3, 12.5, and 12.6 all together. And the reason we're doing this is because in the book, they actually have you do 2-column proofs for what we're talking about today, and you're not going to cover that until SM2. So we're kind of taking little bits and pieces of each one and putting those together, and it flows very nicely. So what we're going to finish chapter 12 with is proving triangle congruence by SAS, SSS, and ASA. Mrs. Oldham, what in the world is that? Well, I'm so glad you asked. We're going to cover that in just a minute. Remember that congruence means that things have the same measurement. I also wanted to point this out. You can't see on the video, and you can't see here either. But this painting is made all out of triangles. So if you look really, really close, each one of these little things here, they're all triangles, and I thought that was really interesting. So if you Google triangle art, this comes up, and it's pretty cool. All right, so if we are given specific information for two triangles, and these two triangles are congruent, then we can prove that they are congruent by one of the following three theorems, okay? And I have this on the first slide. S stands for side, and A stands for angle. So we've got side, angle, side, or SAS, side, 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 SSS, and angle, side, angle, ASA. And we're going to cover all three of those. Okay, so first of all, the side, angle, side congruence theorem. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. And then they give you the congruent statements right here. Okay, looking at pictures of the triangles really makes it easier. So if I've got a side and an angle and a side, and they're congruent to the same side, angle, and side, okay, then we know that the two triangles are congruent. Okay, so that is the side, angle, side. All right, so show how, what we've got here, show how ABD, so this triangle right here, show how, ooh, that looks terrible. Show how ABD is congruent to CBD. Okay. Well, what we've got here, since we're learning about side, angle, side, we're going to show how the sides, the angle, and the sides are congruent to each other. So, first of all, we've got this right here, and we know, because it's just one little tick mark, that those are congruent. So we can say that AD is congruent, so AD is congruent to CD. And that's a given. Okay? We also know that this is a straight line, and this is a 90-degree angle. So if that's a 90-degree angle, then we know that this has to be a 90-degree angle. Did you hear that? A 90-degree angle. Okay, so we have angle D is congruent with, I'm just going to call this angle E. Angle E. And lastly, we have this line right here. And it's only one line. Or I guess you could think of it as two lines that are backed up against each other. But wouldn't that line be congruent to itself? Okay, that's called the reflexive property of congruence. And you'll need to know that more next year. But for now, what we can say is BD is congruent to BD. So, here's one of my sides, here's one of my angles, and here is a side. So we have proved that these two triangles are congruent based on my side, angle, side. Okay, so what about this one? This one's a little trickier looking. And in this problem, the triangles that they want you to see are actually this triangle right here and this triangle right here. I know sometimes they overlap, but those are the two. All right, so let's look carefully. We've got two pairs of sides that are congruent, so we can write those. We have JN is congruent to MN, okay? And we also have KN is congruent to LN. Well, somehow or another, we need to show that this angle is equal to that angle so that we have the side angle side. Remember that the angle is the included angle, so it's got to be nestled between those two sides. Okay? And we actually do know that these are congruent to each other because of the vertical angles theorem. Remember, we kind of talked about that before. It's the bow tie theorem. If we have two lines, those are congruent. Those are congruent. Okay, so in the middle there then, let's call this A and B, angle A and angle B. We've got measure of angle A is congruent to measure of angle B. So again, there's our side, there's our angle, and there is our side. Okay, so the side, side, side. That's telling me I need to start another video. So we will cover the side, side, side in the next video.